directly in Unity as well. So keep expanding on our technology. Now, to democratize gameplay, of course, we just don't need this engine that's out there, right? So we have other parts of Unity that we want to do, and this is how we do it. So the biggest, most important thing for us in Unity is you guys, the community. Right? You guys are the most important part of us, because without you guys, Unity wouldn't exist. And that's why we're here. That's why I'm here, to actually try and build a community, support the community. So far, I've been really impressed by by the stuff that's coming out of Indonesia. So, like you mentioned earlier, I've had a long history of game development, about more than 15 years of game development, and so has Indonesia as well, right? Indonesia's been making games back then. When I started, yes, there were game development companies here as well. Of course, there were like 2 or 3, same thing like in Malaysia, 2 or 3, but it came from there. And it's been growing and growing really big. And the coolest part about the game development here is that it's not just staying local, it's going international, right? So, truly awesome job. And that's why we're here, and we're really excited to be here as well, to build that community and help build that community. Which is also why, if you want to look for help in Unity, like, there's not just the documentation, but the forums. The forums are really, really important to go to, because that's where all our community hang out. They throw questions there, they answer your questions, and so you've got very highly experienced developers that are on those forums, right? So don't be shy, okay? I know sometimes language barrier can be a bit difficult, but on our forums, no one cares. Don't be shy, as long as you have some examples to show. You're nice and polite, not rude, right? You don't troll, it's fine. It's good. And even some of our top developers internal. So you've got our VP of engineering to our CTO, to our top graphics programmers, our top engine programmers, all hang out in forums. They also answer questions, right? So there's nowhere else that you can actually get better help than in our forums. So yes, participate, become part of the community. It's really, really important to us, okay? And then later on, we're showing you as well, we're talking about some other things that we've now, with Unity 5, that's going to be coming. We're also expanding on what we're going to be doing. So, so you made your game, right? You're done, you're ready. What's the next step? So after that, right, it's about then being successful in selling your game, correct? And that's what makes you a successful developer, so that you can make a living and you can make more games. So again, because we want to support that, we are going to be incorporating a few things like Unity ads. Right? We just bought a couple of companies like Everyplay, Amplifier, I can't remember, a few other companies, and we're taking the technology and putting it in. So Unity ads will be built in. You can actually monetize on ads through your Unity games. There's also Everyplay, actually like a video playback where you can actually capture parts of your video and then share it with people as well. And that way you can actually get more exposure. Right? So it's sort of like marketing and advertising your game while you're advertising other games as well. So we want to incorporate all these things because that is the actual next step, the important step of actually becoming a successful developer, right? Is monetizing your game, bringing it to market, and getting the exposure, the international exposure. And that's what the services that we are putting in to actually help you become better developers, right? And then we've also been, so again, towards the end of this video, I'll talk about our cloud build, our cloud services, and our collaboration, which we're also adding, again, more features, more functionality, aside from just development, to actually help you become better developers. So, once now it's full, more people have come in. So I'll just play this is the Unity 5 trailer video that we released that we released in GDG that kind of talks about all our little features that are coming in Unity 5. So I'll keep the audio low so I can talk around it. So we've got real-time global illumination. for mobile, desktop, and console. So you're going to get this in mobile as well. And that's running on a mobile tablet. We've got reflection. You can see the reflection of the ship is actually reacting to the lighting. And the big one is we've got physically based shading, which is the next generation that's coming up. I know you may not be able to see this video now, but those of you who haven't seen it, you can also catch the video on YouTube. It's on our YouTube channel, the Unity YouTube channel as well. This is the just released 4.6 version, which has a new UI tool. And then one of the big ones is our audio capability. So all your audio guys out there, this is really exciting. So here, you actually play the game and you adjust your values and you save the values back. And real-time audio effects as well. So we're basically adding audio tools and audio functionality that's never seen in other game engines at all. So here we're showcasing a feature called ducking. And ducking is basically like when you've got the music, and then you want a sound effect, and you can just bring everything down and then bring it up again. Adding more 2D physics vectors so that it'll be easier to actually make some of your physics style 2D games. Directional forces in 2D. And this is one of the nice things as well, one-way collision. If anyone who's made a platformer knows this can be very painful to code, so now it's there. We'll be supporting WebGL, and that's the one big thing that's coming next year, WebGL. All supported on all of the browsers right now. So yeah, so this game is actually running on a browser. And we've got tons of performance boosts in terms of profiling, in terms of the whole editor is now 64-bit. So 64-bit, you have access to a lot more things like threading, multi-threading. Yeah, there's a whole list of new things: physics 3, HDR, LOD, tab mesh, compressed QFlat, a whole series of animation improvements as well, and added functionality. We're adding more functionality to the state machines in Mechanim. So you'll get to see some really, really incredible stuff being done. So instead of just the animation, we actually use the state machine, anything with motion. If you're not sure what root motion is, don't worry, I'll be talking about it later in the next session. Here we're talking about Unity Cloud, like mobile applications. How it's actually really easy to implement as well. Just a couple of lines of code, throw it in. So now you don't have to suffer about trying to get those ads in as well. So again, trying to make that game development process as painful, as painless as possible for you guys. Okay. So yeah, so in case you missed anything, you want to watch it again, the videos on our YouTube channel, along with a lot of other videos that we have there. So yes, so some really, really big changes coming along. And I think one of the big ones is when it comes to 3D is the physically based shading, or physically based rendering, whichever way you look at it, right? It's so new that even the whole entire industry is still trying to decide on names, still trying to decide on terms. So as a 3D artist, one of the big things is that you will face a lot of changes. To work with new technology, you will have to actually slightly change the pipeline that you are used to. The way you create your diffuse textures, your normal, your specular, all that will slightly change. In Unity 5, we're also changing some of the way the code works as well. So porting your game from the 4.0 to 5.0 will actually cause some errors to come up, but we're actually trying to create some tools which will actually go through your code. One of the reasons is that we're making big, huge changes in the way the core technology, the way the scene works, so that it actually expands and gives us more functionality. Like a lot of things which were not possible before will be now possible in 5.0. Right? So naturally there will be a bit of a slight painful jump. But in terms of physically based shaders, one of the big things, I'm not sure if you can see in the screenshot, but so normally, if you're used to using Unity or even some other ones, excuse me, one of the things that you normally do is you actually have to create a shader for each material, right? And then you actually drag and drop each one, and then you have to like say if you want a reflective shader, then you use a reflective shader. If you want one with normal map, you use a normal shader. If you want with transparency, use the diffuse transparency shader. So then you end up with 3 shaders, right? And then you end up with a library of shaders that you have to keep dragging and dropping. So with Unity 5, it's one universal shader. So we call it the universal shader or standard shader. So the way it works is that you just drag it and drop. You'll see the list of features in there. So if you put a diffuse map, then it will use the diffuse. If you put a transparency, it will use transparency. And it will take that shader and then on build, it will remove what is not needed and send it through. So it doesn't become a heavy shader. It makes the art pipeline or workflow very fast, so you don't have to get confused with, oh, which one do I use? So we're actually putting it all into one shader, the standard shader. And that way, artists can easily not worry about things and trying to figure out which shader to use. So that's a big boost. And so with this, it gives you the ability, and it makes it easier for artists to then create objects with real-world material, right? So now, you take a texture map, you throw it on a table, and you look at it, and it doesn't look real because it works differently with the lighting. It works differently with the ambient light, with the internal of your point lights, right? But with physically based rendering, it starts using real-world examples, real-world calculations, and so it's based on the concept of how in the real world there's only metallic and non-metallic materials based on these 2 things, right? And so then you actually use like the specular map to actually differentiate between these 2. So it makes it easier to actually make realistic looking stuff. So yeah, so let's move on. So the other thing is that one of the services that we're adding is the Unity Cloud Build. Okay. So typically when you build a game, when you're making it and you have to hit build, so yeah, you have to manually make builds, right? You sit there, you do your thing, click desktop platform, hit build, wait, right? Gets built, run the exe, okay, go back, make some changes, right? Hit build again, okay. Then also, if you go like, okay, now I need to test on iOS, you switch platform, right? Boom, all the assets get re-imported. So you sit there and you wait, right? So it's not a waiting time, but you want to be actually doing stuff. And then uploading builds to devices or other computers, yeah, so you built it, then you send it, email it to your friend, email it to your other partner, so that he can get it on his device, that kind of thing. So all these things get really, takes a lot of time, right? So in the end, just doing build can take up 2 to 3 hours a day, right? And if you times that over the week, right, that's like 15 hours. So half a day was gone just waiting around, right? So that's, and then if you look at long-term production, if half a day a week, then 1 year, you know, you've just lost 50 days, right? 50 days of actual work because you're waiting around. So that takes a lot of time. So what we do is, what we have now, the cloud build is, so developer team next changes the source code, sends it to there, it's called the source control, right? It then goes up into the cloud, detects it, goes up into the cloud, and it builds in the cloud, right? While it's still working, right? You send it, boom, you're still working, it's building in the cloud. And then you send it to a device. So you just have to hit build and keep on working, right? So, yeah, so it's really cool. So what you do is, your project gets, like using version control, the project gets uploaded to our cloud, right? So what you do is, you hit update your version control, hit build, it sends it to the cloud. It's building in the cloud, you're working on your game. And how you assign what is happening in the cloud, so like for example, you'll build it to iOS, or you build it for PC, it'll do those 2 builds for you, right? And then it can send, it'll create a link, and you can send that immediately to your tester, to your client, to your publisher, while you're still working away. So you can just hit build and just carry on working. You don't have to do anything else, right? So the one that I tested was where I was like just doing it, did a web player build, right? Sent it up, creates a link, email the link to go to my friend to test. I'm carrying on working. So you can just keep doing it all the time while you're working. So no more waiting, right? So that's where the cloud build is really, really awesome. It's awesome. So it automatically makes build in the cloud. Anyone can pick up a build. Everyone can test their work. So now, typically, let's say I'm on the machine, like I'm coding and I'm doing stuff, and I need to test out, artist wants to test out the level, right? He'll come to me and say, can you build this for me? I'm gonna stop my work, take the level, okay, build, test it out, right? Here, it's like the artist click build, it goes to the cloud, right? Doesn't bother me. Because I'm sending my updates to the cloud, he's sending it to the cloud, right? So he can test it on his own, totally. So that way, everyone can test their own work. So this is super, super cool. It just saves so much time. So you easily share a build with teammates, collaborators, clients, and publishers. And the cool part is, right now, it is available in beta. So if you are a Unity Pro customer, if you're using Git, SVN, or Perforce, if you're developing for iOS, Android, or web player, it's free for beta. Okay? Excuse me. For now, it's free, right? So yeah, if you have all these things, you're doing all these things, you can go back now, log in, create an account, and try it out. At a later time, we will be supporting the Unity Free as well. Okay, so right now in beta it's for Unity Pro, but later on we are working to make it available for users who are using Unity Free as well. Okay, so yeah, so you guys are in the studio right now building a game on one of these platforms. You got Unity Pro. Go back and try it out. It's free. All right, so it's super cool. Okay, so that's it for my Unity 5 presentation, or my Unity presentation. Do you guys have any questions on yes?
So does that mean we need to upload all of our assets to the cloud?
Yes, yes. At one point it will go up there, yes. So that because all the assets that are needed for the build. Yep. Of course, there are certain questions on security because your whole project is going up there. I don't have all the answers. But our guys have been working on it and working with big publishers and big companies to actually, and they're actually on board saying, okay, the security is good. We don't know whose project is whose, right? So we can't tell you like, oh, this company, this is their build. Let's go test that game. We don't know. So it comes up, the data is there. We don't know anything, right? So that's one of the biggest security concerns. And then of course there are other ones like how safe is the data, that kind of thing. And we actually have like one of the top guys in data security working on our security as well. So yes. So that's why, because we have to have all the assets on there, yeah. And yes?
When we are using Unity Cloud and we working using a Windows, can it also good for the iOS?
Yes.
Even we are using a Windows?
Yes. Yeah. Because it's built on the server. Yes. Exactly. Right. So that's one of the cool parts as well. You can build iOS, you can build.
But we can build the icon.
Sorry?
We get the icon.
So I haven't tried that, but I suppose somewhere I've only seen the APK and the web player version. I haven't tried the iOS myself. Yeah. So it should be for both, whether you're working on Mac or Windows.
It can export out.
Yes. Yeah. So as long as your provisioning is correct, and, don't take my word 100% because I haven't tried it. But for Android and web, I've tried it no problem. So.
Will Unity Code can be able in our own server?
Sorry, say again?
Unity Code is currently we need to upload all the assets. Right?
Yes, yes.
Can we say
You use your own server?
Yes.
No. Otherwise, it won't be Unity Cloud, right? It'll be your cloud. So there's no My Cloud service. It's only Unity Cloud. Yeah. So everything is done on that. Because there's a lot of technology behind it in working with the different Unity versions, working with version control. So I don't think that even providing it as something that users can use is actually a viable option, because it'll be quite intensive to actually set up.
So this Unity Cloud is just for helping for performance, and does it work like Git for like having some version of your?
So you would use Git, you would use Subversion, right? But it then takes it from there and makes the build for you. So your machine's still available while you're working, right? So that build time is done somewhere else. Yeah, that's the whole point of the cloud. At this point, the cloud build. Yeah, Unity Cloud build is part of that. It's just basically so that your machine is not locked up. So especially if you're having big games, you're having a small game, right? Then of course making a build is like, right, really fast, right? But there are larger games where the build is like 2-3 hours. So that's when you're like, you can't sit there, boom, okay, go watch a movie and come back, right? so what you do is you send it, build on the cloud, and you keep working. so yeah. Something that will be coming later on that we're actually working on now is collaborate. Right? That is something that we're working on to try and bring easier collaboration for small teams. So it's like for some kind of versioning control. So we're also working on that right now. That'll be part of the Unity Cloud services. But build is available right now in beta. Cool? Yes, sir.
I actually have two questions. First, number one is, does Unity has editor for Linux? Linux editor for Unity?
Sorry, I didn't get the word.
editor for the Linux?
No, Linux editor. No. Sorry,
no.
no. Only no, not yet. There is no. There's no news of us working on a Linux editor. It's only Windows and Mac at the moment. Yeah. We talk about it internally. The developers talk about it, but right now we don't see enough traction to actually pursue it. Yeah, because we want to get all this right first, and then maybe later down the road. Not sure. And you.
Second question is, I believe you're using universal shader now. What if we want to make our own shader?
Yes. So the universal shader, so you can still make your own shaders, right? And we're also providing the source for the universal shader as well. So you can also use the universal shader as your own, as a template to start with. Yeah. But you can always make your own shaders, yes. Still supported, yes. Cool. Any other questions?
Can you explain about the optimization by code, like Lightning? How Unity optimize it for mobile games? Can you explain it?
Okay. Well, some of the things. So Unity, when it comes to mobile, right? Unity does only some optimization, right? It automatically, okay, some. Because a lot of it you actually have to do yourself as well, right? Like for example, baking. So baking lights into your scene, right?
Yeah, because you know that when we use Lightning in our game, our game again become slowly late.
Yeah. Yes.
Oh,
So
can we-
So that's with all mobile devices, because mobile devices just don't have the power, right? So you have to actually go do a couple of things. One is real-time lights, right? You can use minimum real-time lights. Don't have real-time shadows, right? Use minimum, okay? So that's why I say with shadows, when it comes to things that don't move, right? Bake it in. So the shadows are not generated in runtime, right? So you bake your shadows in, and so game development is about magic. It really is, right? There's no thing where it's like, oh, this is real physics, real.
Yeah.
No, it's all fake, right? It's all fooling you, right? So what you see looks like a shadow. No, it's not. It's a texture on a polygon. Sometimes we do that, right? So that's how we optimize, right? Like for example, one of the features in Unity is where you can add light cookies. Okay, so you take an alpha map, you put it onto a light as a light cookie, and it'll project that texture like a shadow, right? So like for example, you put it over your character, right? And then it looks like a shadow from the character, but it's not. So there's no light calculation, nothing. It's just projected. So it's really fast, right? Exactly. So I've even tried. We even do tricks like I create a. Is that my phone? No. Normally it's my alarm.
What can somehow?
So like for example, what we do is sometimes we take an animated character, take its movement, render the frames, right, and then project that as a shadow, so that the real time doesn't have to calculate shadowing. But to the player, it looks like, oh, hey, there's a shadow. So you're always doing this. It's always fake. It's always trying to optimize, trying to fool the visual to think that it's something else. Yeah. There's also tricks like what we do is so instead of a light map, instead of a lighting up an area, right? We actually again project texture with the additive, right? So then it looks bright. Yeah. So it's actually a texture and not an actual light, because the light is actually more expensive, right, than an additive texture. Although additive texture is a 2-pass drawing, but it's still less. So yeah, so there are all these things. So always remember it's about tricks. It's always about tricks. It's never about throwing something in and going, okay, like the real world, have this light, project this. Yeah, it's not. It's magic. That's what we always say in game development: is smoke and mirrors, right? Cool. Yes, sir.
I developed games and apps with NUI framework, but it's really painful if I type the script in every line on my editor. Is there any solution in Unity for an UI game so player can play games with their natural gesture?
I actually don't know. I'm sorry, I don't know. But you're using NGUI, right?
Yeah.
So 4.6 we just released has our own UI, and so it might be better, right? And it might actually give you more control over the UI. Yes. So I would actually try out our new GUI because in case so you're talking about GUI and asking a question about that. In case none of you have tried it before, so he's using a plugin called NGUI. Right, and it was one of the most popular GUI solutions. In fact, whenever people would ask me, right, what GUI to use, we would say NGUI, right? But 4.6, which was just released last couple of weeks ago, right, has our new Unity GUI solution, which was actually developed by the NGUI guy. Yeah, so we hired an NGUI guy, and he came in and he helped us develop it. So give it a try, right? It's available out now. There's also some very quick tutorials available on our Learn site or our YouTube channel to actually show you how to use the new GUI. It's actually pretty awesome. So I think it's actually like, you know, because we looked. So the guy came in, we looked at NGUI and said, what does NGUI do well, right? And then what else do we want to do with the GUI as well, right? And then we incorporate that to try and make a even better solution. So yeah, so give it a try. Anything else? No? Cool. Okay, so I'll move on to. See, I've been coughing so much, it brought me a second bottle of water. Then I have to go to the toilet after that. Okay, so I will now move on to our second section. So everyone's okay, right? Does anyone need to go for a break or anything? We can just keep going, yes? No problem? Yeah. Okay. So this session I'm going to actually talk about the mechanism animation system. And the mechanism animation system is actually, for an animator or for an artist, and in fact any game developer now, the way the system works is actually very, very cool. It's a system that has not been used by any other engine. The features that it has is not available, and it is something so new, and to me it was kind of groundbreaking. It uses some things where, as a game developer, I never imagined, right? In the past 15 years, I never imagined that someone would come up with a system like this. So when it came out, this actually came out in 4, when we released Unity 4, and what it does and how it works is just, for me, was just mind-blowing. I was like, oh my God, I can't believe this is real. Right? So that's why I'm excited about it, and I know a lot of people either have never tried it or struggle with it, so I want to share some of the things that I use it for and how, and what the problems it solves. So one of the things about Unity is that we always look at what we call a developer pain, right? What is the pain that the developer faces, and then how can we solve that pain, right? Every time, any kind of feature we have, we never look at it and go like, oh, this is so cool, let's put it in, right? Sometimes we do, but you know, but most of the time we actually look at it and go like, what are the pains that developer faces? How can we solve that pain, right? How can we take that pain away? So the pain of animation, right? So how often do we actually see a character come in and you're like, oh my God, it's all messed up, you know? No, he's not trying to be a wayang kulit, right? It's like, So some of the main pains that we have with characters and with animation is, first of all, retargeting animation. So you have a skin mesh, which is a character with bones, right? You make the character with bones, and every bone has a name. So it has left hand, left upper arm, left lower arm, left hand. Okay? And sometimes, you know, artists will make a character with 01, 02, 03. Right? Then, so when you animate it, right, the animation needs to match, right? You've got an animation, you've got a character model. This one is left hand, left upper arm, left lower arm. This animation has 01, 02, 03. It doesn't know how to match up, right? Because it's two different bone structures. So what happens? This happens. It comes in, you throw your animation, and the 01 goes to the left leg, the 02 goes to another body part, right? And everything goes crazy. So bone names always have to match up, okay? That's the one big issue when working with when working with animation. So if you have a character that you have rigged, you've got your bones all named properly, also fine. But then you go and see, okay, we can buy some mocap data, or we can download some free motion capture data from the net, right? But that one is also named different, and it's not wrong, right? Because you've got left upper arm, right? Left lower arm, and this guy has tangan kiri, tangan kanan, right? I mean, it's not wrong, right? But it's different. So again, data doesn't work, your mocap files don't work. So you're like, you have to bring it into a program like 3D Studio Max, retarget all the keyframes, and then, you know, and then export it out again. So that's a long process, right? So imagine if you have, like, you know, 100 animations, right? And each one takes like 3 hours to fix, because it does take that long sometimes, right? That's 300 hours of work, just fixing the animation, right? Not even working on the animation, just fixing the animation. So then you get the mocap files with long sequences, right? It's a long sequence because they capture the data. So like, for example, there's a jump data, right? But when they capture the data, you see the animation start like this, right? And then the actor is like this, and then only he jumps, right? And you only want this small piece. But you actually then have to take the file, import it into Max or Maya, remove the keyframes, and then re-export it out. Same thing, another 2-3 hours work, right? Faster, more experienced artists, maybe half an hour. But of course, you know, some of these programs are kind of big. Sometimes to even launch, Maya takes like, 10 minutes, so it takes a long time. So, a lot of pain. And then animation flow in game. So, Animator has all its animation. So you've got your idle, then you've got your walk, right? And then you've got your run, and then you've got your run left, run right, and then you've got your jump, and then you've got your duck, right? And then duck, did you say duck? Die, okay. Duck, you know? Not eating, duck, right? So, die, right? So then you've got 4 kinds of die, right? You've got die while he's walking, die while he's running, right? Die while being shot, right? Die while being stabbed, right? And then of course you've got your walking with gun, walking with spear, walking with handgun. So you've got this whole long list of animation. And then what happens? You go to the programmer with this, you go type out all the animations, you go to the programmer, here you go. Right? Put these animations in. Programmer sits there. Which one first? What comes after that? And then from this one to which one? Right? Because sometimes also, you know, it will be like, you know, run 01 final. And then die 02 final 2. Okay, and then after the die, what do you want him to do, right? Or maybe he falls down, and then what do you want him to do? So that flow becomes difficult, right, to understand. So then the artist has to go back, draw a flow chart. So he does a flow chart, right? Okay, this animation, go into this animation, this animation, go to this animation. So again, long time, right? That also can be a very painful process, especially when you're working with huge number of animation files, right? And even like sometimes you'll be working in between files and trying to, having blending between these files. So again, getting the information to the programmer who's keying all this in is a long time, right? It's a lot of work for an artist, and it's a lot of work for a programmer as well. Because then the programmer who really wants to work on the game AI, right? Instead of working on the game AI that day, he's working on putting all his animations in, right? Typing in all these different animations. That takes up his time as well, when he could actually be working on something more important. Then there's animation blending, so like I said, there's also animation blending. So, with the magnetic system, okay, we wanted to solve a few of these problems. So one of the ways to solve these problems is, let me open up one of these. So, the way it works is when you bring a SPX file in with animation, all right, there are a few options. So naturally, in the import settings, you have model. You choose what kind of body type. All right, so you've got the legacy. Generic is for non-humanoid, and then you use a humanoid for human character. Then you've got this animation portion here, okay, which has, this one has no animation right now. But we're missing a little piece here. Okay. So let me just pull up some of these guys. So on the rig portion, you hit configure, and you get this. So what this part is that we create what we call an avatar file, right? Nothing to do with the movie, but an avatar. And you assign all the bones from your character to this portion here, okay? To that body. And as you can see over here, let me scroll this up. So you've got all the different pieces here, all the different body parts that are linked to each part of your actual character. Okay? So this is done automatically. So you don't have to do it manually. Right? What it does is, this is quite cool actually, is that it actually, because you set it as a humanoid, and common generic humans have a fixed set of legs and hands and body parts, right? So of course, it doesn't support 3 hands and 4 legs, right? A normal humanoid, okay? 2 legs, 2 arms. So it already knows, right, that from the pelvis, the moment you go up is your stomach, your chest. The moment you hit the chest, it knows that anything going this way is going to be the right hand and the left hand, right? The moment it goes right shoulder, it knows that anything going here is going to be right upper arm, right lower arm, right hand, right? I mean, a leg can never be attached to this, right? So the software actually knows. So it looks in your actual model, goes tuk, 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 and immediately assigns everything automatically. So you don't even have to do anything. You don't have to manually assign it. So that's so from a 15 to 30 minute job becomes 2 seconds, right? So that's so cool to me. I mean, I've sat there and done it manually before. It's not fun, right? So that's why I'm like, oh, awesome. And you can throw any character with any name. I mean, look at this. This guy has like R middle proxy 03 geo, right? R pink. I mean, that's it. Right foot, right ankle proxy geo. So his bone names are just like crazy, right? But they all work. So it goes to the left shoulder, goes to the upper arm, goes to the lower arm. So what happens is, because of this avatar file, right, which has all these ones here, so then you can bring another character with completely different bone names, and it will always look at this file, right? It's like a translator, right? So you can be speaking Indonesian, you can be speaking English, doesn't matter, the translator is here. And so that's what it does, and it does it automatically. So again, hours of work completely done for you. So that's the part where the retargeting, you don't have to do it in a 3D program anymore, right? So you can download, like for example, over here. So this guy is like this. I've also got another file. See, so this one is using the big 001 pelvis, big 001 spine. So these board names are completely different. And this is one which is very popular because it comes from using 3D Studio Max, the Character Studio. So the names are completely different. And I can use all these files together. Don't have to worry about the bones. All right? So now, then, let's look at the other cool part. So we have that. Targeting, solved. Right? Hours of work, no problem. So what's the other part? The other part is taking all the animation sequences and working it together. So again, you don't need a list. So what we do is, we have what we call an animation state machine. Okay? So this is very, very, I would say, simple, easy to use, user-friendly, and so instead of writing a whole list of animation names and then giving it to the programmer and telling him which ones to use, the artist now doesn't even have to talk to the programmer. Artist goes into the animator and sets up the animations. And it's simple as, I'll just quickly create a new one here. Just create one. So animator controller. Okay, I'm just gonna enter on this one. So it starts up like this. Okay. Then I've got a few animations here. So I've got my idle animation. Drag it over here. Take this one I've got done. Drag it over here. Right? And then I want to blend or transition from one animation to another. I just right click, make transition, click, right? And then to control the transition, what's happening inside, I click on this arrow, and then I can actually adjust the blending, right? How it blends from one animation to another, okay? Then after that, I say, okay, make a transition back to it, and you're done, right? So you automatically go from one animation, blend to another animation, and then back to this one. Super fast, super simple, right? Don't even have to do anything. Don't have to give a list, save the file, programmer takes it, it works, right? So now we're going to come back to this to show you a more complex one. But before that, let's go back to our little animation here. So, remember I was saying, this one is one actually, one that's okay. There we go. So then, remember I was saying, we have mocap data, and we only need a small part, right? So then how do we edit that animation keyframes? So normally you would take the file, import into your Max or Maya or some other 3D program, Blender, and then remove the keyframe, separate it out. Again, long time, a lot of work. Now you import your FBX. Right here, first of all, you can preview your animation. Okay? Yeah, you see it? Yeah. It's running down there. Okay? And you'll see the entire length of the animation is here. And what you do is you adjust the timeline to which part of the animation you want to use. So I can easily go in and say where I want to use this animation. And that's the only part that it will take when you build a file. Right? So optimizing, right? Normally what you have to do is go into your 3D program, because you don't want an animation which is I've seen like 20 megabyte animation file, right? But you only need this much. Okay? you don't want to just load up that whole thing, right? You need to edit it. So you come in here, you use that portion, the rest of it will be removed. It'll only, when you build your game, it'll only take this much. So you can have these big files, and you can set it up this way. Because mocap files can be really huge, right? But this way you don't have to go to your 3D program and export again. Again, a lot of time saved in actually working with animation. And it's done by the animator. So another part is, like when you create your run cycle, you want it to loop, right? So you want the first frame and the last frame to match up, okay? So normally the animator will go through, find, visually look, okay, this frame, his position is like this, go to the end frame, his position is like that, and then slowly match up, right? With here, what you do is, you can drag this along, and you can see that the lights are changing. So those lights are telling me if this frame and this frame are actually matching up, whether they match up. So I don't even have to look at the animation at the bottom. I can actually look at those lights there. So green means it matches up, right? So again, very quick, very easy. Just go green, first frame, the last frame are the same. So now it'll actually look nicely. So again, this a lot of time-saving tools that help you as an animator or help animation actually work a lot better. Okay, so we've got that, and then we can go back to our animation state machine. But here there's a couple of things really, really cool, and to me it's like very exciting as well. Let's go back to our robo character. Okay. Now there's two portions here where you'll see that I have all these animations, yeah? I have my jump, my run, my idle, right, my walk backward, okay? And when I actually play it, okay, so this is my character. He's there, then he's ready to walk around, so he's running. I press forward, he's running. I press backward, he's walking backwards. Okay, and then when I to my left, he turns, to my right, he turns. Okay? Now, typically, you actually have to tell, so there's two portions here, right? If you work on animation and games, you'll know that there's two things that happen here. One is, you have to tell the programmer how fast the character has to move. Correct? So the programmer will be like, how fast are you running? Like, oh, you know, he's running at what speed? So you tell him he's running at 2. Because there's no real number, right? Right? It's like 2 meters a second or something, right? There's no real number. It's like he's running at 3. And then what happens? He's moving like this. Correct? He's just sliding along like that. And you're like, no, he's moving at 3.2. Right? And then still a bit better, 3.25. But you still see a little bit like 3.255. Yeah. So you're sitting there trying to like find this, right? So you're like, okay, that's a big problem, right? Then the other part is, again, like when he's moving and he's blending, so normally you go like press key, okay? So this is a programmer thing. Get input, press key. How do you move the character? You transform him, correct? You transform the guy along, the Z axis, okay? So he's going along. Then you rotate him. You rotate him by Y. He's here now, right? You rotate him by 45 degrees, right? What's his direction now? Because the world Z is here, right? So what is his rotation? You don't know where he's facing now. So programmers have to keep track of where the guy is facing all the time, correct? Because otherwise you don't know where forward is. Because you're always transforming on, so you have to transform Z, and then you have to transform in another direction, and then if the character jumps and rotates and plays around, what happens? So your direction is also gone, right? The programmers actually have to keep track of where the character's direction is always facing. in this 3D world, which is again a lot of math, a lot of calculation. So then when the, even I am guilty of doing this, right? Where you want to have an animation, right? Where the character does some fancy move, right? But then he ends up here. And you're like, can animate the other way around. You know, make him finish the same way he's facing, right? So that you don't get into trouble. So that also is a big issue. So then the other part was also how to transition, right? When to die, when to jump, when to do these things. So this is the cool part. Now, to quickly load up something else for some of you guys to see the code. So that's load up. So when we animate our character, like a run cycle, what do? We animate them on the spot, correct? We're animating on the spot. We're looping like this. And then only you move, transform forward. So the character is actually just running on the spot here, right? And that's why you get that feet problem, sliding feet. So with Mechanim, what you get is root motion. So root motion, okay, you don't need to transform the character in code. There is no transform in code. You actually use the movement in the animation. All right? So transform, your example here. So normally, this is your character, this is your axis, right? If you normally, so you animate him running like this, and then you're actually transforming this axis, correct? If you actually take an animation file, and you have it animate, right? Normally it'll be like this. It'll be moving like this. The axis is still here, right? So when you loop back here, correct? You see you always come back to its position when you don't transform, okay? With Mechanim, it moves here, the axis automatically updates. Completely, totally, automatically updates. It follows. So the animation movement is no longer set by code, it is controlled by the animator. The animator makes you move this much forward, the character moves that much forward. And you can get, it updates the position, so all you have to do is just get position and you already know where it is. So in my code here, okay, there is no transform character. There is no transform code. All I'm getting is get axis. I'm just getting a horizontal input and a vertical input. I'm just taking horizontal and vertical input, right? Key. No transform. So how does the character move? And this is where the awesome cool part comes in. So over here, I got my transition, right? Idle to run, okay? So when do you move from idle to run? I set the condition, speed. So I create a parameter. So again, animation does this. Create a parameter. Programmer just looks speed. And when speed is over a certain level, so speed is greater than 0.1, it automatically plays the run animation. And when you play the run animation, because there's root motion, the character moves. So there is no code in there that says get input, play, run animation, move, transform character, none. All it's doing is taking the speed, sending it. The state machine is always running. So when the state machine goes, speed parameter is over 1, do this. So your coding is actually here, in this part. You're actually creating the code for going from idle to run in your state machine. So that way, everything is done automatically. So you don't have to keep updating. You don't have to care about direction, right? Again, direction is purely from the animation and it updates. So if your animation is rotating, then it knows that it is going to rotate this way. So that way, it always updates, always updates. So adding animation and updating your animation is super fast, super easy, and it's purely in the control of the animator. And that's what's really exciting for us, because then programmers don't have to worry about it. They don't have to sit there spending all this time trying to get the animation in. Animators do everything in here. Give the file, programmer, all the programmer does is, see, I just get a key if I want to change, like jump, right? I've got jump and a dance animation, and that's it. Everything else is just horizontal and vertical, nothing else. That's the entire code, right, for having this character do this. Where he is, running forward, running left, running right.
Jump.
Yep. Oh, jump. Oh. Okay. I thought you called me Joe, but yes. Yes. And then jump. Right? So he actually, and so you see, he notices his jump. Oh, that's not jump, that's a dance. Okay? So now check this out, right? So now he's facing in a straight line. Okay? Now he turns and he's dancing. And now he's facing somewhere else. And when I press forward, he just moves forward. So in the code, again, there's nothing. Everything is done in that state machine. Right? Super fast, super easy. Some confused looks here. Any questions at this point? No?
How about the animation?
Sorry?
Why the animation? When I have spider in my hand,
Yep.
how to animate it too?
If you attach it to the actual board, it will follow. Yes. Yep. So, and this one actually has a collider, a big collider, a character collider as well. So cool, right? Yes.
So basically, the mechanism use inputs from the user like keyboard or something.
Yeah.
What about say NPC character?
Can, no problem as well. So
How about the coding?
So you would actually just call the animation. So it doesn't have to be just input. It's basically in code. You would say play animation, and the character will walk. And just to show you, same thing as well. It'll follow the animation. It'll actually follow the animation. So like for example, so his question was, what about NPC characters? Because here I'm showing you input. There is a model that I got. So what about NPC characters? So NPC characters. So the thing is, all you have to do is, one is start animation, right? So the animation is idle. You call walk animation. He will walk. Make her, right? And what you have to do is, you just have to send him in a direction. Say look at another direction. He will just move and walk. Right? So it's all actually set up very automatically. If you actually, because it's using the animation, then you can actually turn and move him in whichever direction. And he will actually update. So before, so let me show this to you here. So actually you can see he's idling now. So you can see he's actually idling here. Okay? And in the run animation, okay? But she doesn't move. So anything between the turn left and turn right. Okay? So my turning is actually my turning animation. So I'm actually, if that run is the turning like this, right? And the turning like this. So instead of having him to turn, and then the typical right? And then move, right? You just have to make the animation and you call the animation. So again, the programmer doesn't have to see. You can reuse all those animations. You just mix it for any character. And just keep going and moving. And because of the parameters, there you go. You know, the ball is happily dancing. Over here, I have a parameter called direction. And over here, so the blend tree, direction. The direction is -1. So you see that it turns blue here. right? Can you see it changing from one to another? Yeah? So 1 is turn right, -1 is turn left. Right? So it's continuously updating the direction. It's looking at the file, going, walking, this is the direction. If the direction changes, right, it's going to go, hey, and start turning. It'll start playing the animation. So it's always continuously updating. I know it's freaky when you try to think about it. Yes?
Can you alter the run speed through using the animation speed?
That was one of the most common questions all the time. You can, but you may not get really nice results. So the question actually, what I normally say is, why are you altering the run speed, right? Because again, old school days, yes, you would actually go in, play back the animation at a different pace, right? But here, what you're doing is you're actually creating animation that is supposed to work in that speed, right? Because before it's like transform, speed, but now you're actually going, all right?
I want him to move this fast to move
Right,
back to his video.
right. You don't have to get, you wanted a slower
Long
one,
bit of
you actually
code.
create a slower animation.
Long bit of
Or blend to that one.
Everything is done super
So
fast.
it's a different workflow, different
Control the
mindset.
animator.
But it's really like,
Go
it's
crazy,
yeah,
try and put it
because it
all
was like
on
before,
different
I actually had to go, you had to go
Programmer
around,
doesn't have to worry.
transform, rotate,
Like I said, sometimes
developers, I mean, you don't do the forward, now
You
it's
sit
just
there and you've got
all
this much
there
of work,
automatically.
and then
controlled
new
by the
animation goes to
animator.
code, code goes,
different.
I've already got this much, tell the producer, I've already got this much time.
It's no longer
I don't have time to do all
code
this
transform driven,
So what
it's
happens?
animation driven.
You cut down
So
the
the
number.
animator gets the full control.
You end up with
animator
okay,
like
let's cut
this
down because we don't have time.
It's complex.
Here you save hours
state
and
machine,
hours and hours of time,
that then everything
so you can
can
get
work
better,
that way.
fuller animation.
And that's what the thing.
Why is it so
How
exciting?
about one
Right.
thing?
Um,
Can we use
And so that's what it means, like, the artist can actually, the animator can sit there and make it all stuff really, really quickly.
You could as well. You could, but depends on what kind of box you want. So, because you can do two, right? You can do physics, pure physics, right? Or you can do actual bouncing like this as well. But then you have to blend all two things. So yes, you could actually use, this is not just for humanoids, you can use it for any animation.
So,
Right? You can use it for
combination of
just moving objects around, right? You can use it for effects, okay? And even some of the guys now, the stick machines, they actually use it for, got the character here. So because this is designed to actually go to the different red balls, this guy. So these are animations, correct? So I'm just going to delete these. Delete. Okay. So, you can actually create an empty state. So I've got empty state, and I call this gameplay. Okay. Then I can call this a pause, right? And then I can make a transition. So there's no animation here. But what's happening is that if I play it. Okay, so you can't see anything because there's no animation, right? So coders now, so if you're coding, when you use statements, you use states, right? So instead of having all the states in your code, you can set up your states like this and just call this. So you don't have to have all your states in your code. So that's what some of the programmers are using this for as well. So that's where it's becoming more than just an animation system. It's actually a state machine, right? A visual state machine. And that's why in Unity 5, just now in the video, it showed you where we're adding on entry, on exit, right? So that we can actually use this. So we can trigger functions, events, on entry to a state, on exit to a state. So it's becoming more extensive even for that. So then it's a tool for coders, animators. It's an awesome state machine, a visual state machine. Yes.
How about we using 2D's bone? We know that 2D's now can use bone for animation.
Yeah.
Can we use the 2D's bones with mechanic?
So the mechanism, yes and no. You can use generic animation, but you cannot use humanoid. Yeah. the humanoid structure doesn't work because the humanoid is 3D. But generic and 2D animations, yes, can. You can use Mechanim, you can use state machine, right? Which is why in the video just now, you'll see that for 2D, you can also edit the root motion in the editor as well. So you can take a sprite, throw it on, create animation, and add the animation, and it automatically keep moving because of root motion for 2D. So yes, 2D all works perfectly with Mechanim, right? Afterwards, I'll show a little 2D thing sample. I think I have that, but I'm not sure if I still have it. But yes. And cool. Any other questions?
For
Yeah.
the swap object, like I have a pen and I want to change it with a hammer.
Okay.
For this one,
So that one you'd actually have a separate object.
in animation.
So what I would do is I would actually have it as a separate mesh. Yes. So it wouldn't be one whole mesh. I would actually have it separate, but the bones are the same. And then attach it. You can actually send AI characters running around doing stuff. Which to me before this was like, I've got this guy set up, crazy to do. Really, really difficult to do. For a non-programmer, programmer might go, yeah. You know? And a couple of weeks, I'm like, just to show you, I do this in a couple of days. How it works, right? So I have another model. And again, it's just simple little code. Okay, so yes, sorry. There is a model that I downloaded from the SS. That's free model. Okay. Okay. And another thing model is with Mechanim. Let me go down. It's a rig, right? It's all there. So now to make her do the same thing, I just need to add a few components. So click on her. Okay. So the jump now is not very exciting. So I just use, what I want to do is, I actually want to use, I want to actually put a particle inside. I just use the same one when he jumps, when he lands, particle effect happens. Right? And once I do that, how do I do that? Automatically, so first of all, you can see again, I need a particle. So I already have a particle here, like that. Here, so this is my sample particle. Right? So you can see that it's already idling now. So I want it to basically, when he runs, he jumps, it's already idling. He spins, right? Okay, when he lands, but that doesn't happen. So I need the script, right? So with the Mechanim system, it's very, very simple to do. First up, script. I actually need a simple script first. Jump, okay, play, this script over here. Okay, now they're both running. I have a function, play effect, and jump. Okay? And then play effect will spawn the particle. So you can reuse all the animations play for any character. Right? You can just programmer can do whatever he does all the fancy stuff, dancing, all kinds of things. I just care about the name of the function. Right? So to show you the transformation, check this out, right? If I move over here, okay, let's look at this. And let me down there, scroll down. Okay? So my forward, right, for the robot is going to go front, and she is also going to go this way because it already knows that the direction is this way. So up is always forward. Right? So that she'll go like that. See? So if you all, I lost her now. Where'd she go? Oh, there she is. So you see? And I'm just using, oh, come back. Yeah, I'll just go. That's maximize. Gameplay. Okay. So yeah. So again, it's always following the direction. Right? So play it. Okay, and using the same script, right? So this, fly. Okay. So then, so animations, putting it together, working with the script. I already have the script on, so you need to play it, right? So what you'll do is, right, when it finds the function call, that's really exciting. I don't have to get into, because it's all bits of code, it'll call a function that's long bits of stuff. Okay, everything is done super fast. It is the control of the animator. You can then go crazy and try and put in all the cool different animations. Programmer doesn't have to worry. Like I said, sometimes in development, I mean, exactly, you know, you'll sit there and you've got this much of work, and then you do animation, goes to code, code goes, I've already got this much, tells the producer, I've already got this much time, right? I don't have time to fit all these animations in. So what happens? You cut down the number of animations, right? You end up going, okay, let's cut this down because you don't have time. Here you save hours and hours and hours of time so that you can get better and cooler animation in. And that's one of the things why it's so exciting, right? And so that's why to me, and who can actually generate and make stuff. So you don't have to go to the programmer and say, so, okay, when the animation of this frame plays a particular effect. So normally in code, what do you have to do? So this one is going to have two things. It's animation playing, find the full length of the animation. So here's a combination of using mechanisms. Okay, so you've got the character here, and super fine to actually go and these events right, to your animation, find its way around, to your state machine. Right? So if I wanted, I can add audio as well. Right? To the same script, I go play effect, goes up there, play particle, play sound. So I can go, so typically, this is add sounds like that. The same character, jump with the same controller, and then throw in boom, right? So okay, now we have some super cool. So how do I find the direction? So this is another cool feature. We've got a character, he's got a unique called the nav kind of thing. Has anyone here used the nav mesh before? No? So this one is a pro feature, right? So it's a Unity Pro feature, and it's called nav mesh. It's basically a navigation mesh, all right? And what it does is you apply it, and then pull up the navigation console. So what it does is it actually creates the area of where the character or enemy or whatever can move, right? So I love this because, for example, so I'm a technical artist, right? So I'm not a hardcore coder. So when you talk about AI pathfinding, A-star, I'm like, huh? Right? Even people try to explain it to me, I'm just like, never mind, okay? Whereas this, you immediately set it up, you bake in the pieces, right? And then it'll find its way. So the blue part is where the character can move, right? So, and that's how it finds its way around. So you see even up here, it finds its way up here with a very fancy algorithm. So like for example, let's say I want to do that. Okay, so I move this guy up here, right? And I just move him around here. Click on this. Bake, and it updates. Then now, when I play, so now he knows that that is the faster way to go, right? Because earlier it went around that way, right? So now he just knows there's a break there. Okay, I can go this way. Because it looks at that nav mesh and finds its way around. So which is where it's very cool. So yes, this is one of the things where sometimes when you see certain games and you go like, you know, that AI pathfinding is really, really cool. How are they doing that? Must be some complex things, right? Sometimes it's not just this, right? So nav mesh is really, really popular for AI pathfinding and really popular for just figuring out the land layout, where to send enemies, how to use, what areas to use. So very, very cool. And it works together, like for example, Mechanim. So Mechanim, nav mesh, with some bits of code, you can actually send AI characters running around doing stuff, which to me before this was like crazy to do, really, really difficult to do for a non-programmer. Programmer might go, oh yeah, it's easy. You know, just give me a couple of weeks. I'm like, I do this in a couple of days, right? And so it's really fun to actually play this. And again, it's just simple bits of code. Okay, so yes, sorry. One more thing. Bring this guy. Okay. So another thing that you can do with reckoning, let me sit down. Right. Let me just test this out. So, okay, he's working, he's jumping. Okay. So the jump now is not very exciting. So what I want to do is, I actually want to use, I want to actually put a particle effect, right? So that when he jumps and when he lands, particle effect happens, right? So how do I do that? So first of all, I need a particle. So I already have a particle here, like that. Okay. So this is my sample particle, right? So I want it to basically, when he runs, he jumps, he spins, right? When he lands, that's when it happens. Okay? So with the mechanism system, it's very, very simple to do. First up, I actually need a simple script first. In this script over here, okay, I have a function, play effect. Okay? And then play effect will spawn the particle in a particular place. So the most important to me is this, play effect. Right? So programmer can do whatever here, he does all the fancy stuff, right? Okay, he can do all kinds of things. I just care about the name of the function, play effect. So I go to my jump animation. Jump animation. Where's my animation? Jump animation. I go to animations, scroll down, and here I have events. Okay? So go back here. Okay, so I can actually see this guy. So when I scrub, he jumps, and then he goes up and boom. Right? So when he lands right here, okay, I want to add an event. Right? Add an event. The name of the event, I put the function just now from the script. Play effect. Right? Okay. You can add other ones, but I just want to do this one effect. So we'll play it. Okay, done. Close this. Apply. Okay. So then, on here, right? Oh, okay, I already have the script on, so it needs the script, right? So what it'll do is, when it finds the function called, the event, play effect, because it's calling a function, it'll call a function that's in the script. It's already attached here. So, when I play, I run, I jump, and boom. Perfect timing, right? Because I've added the event exactly to that keyframe. Sorry, no dance yet. So yeah, so then as long as I just keep going, so that's how fast you can actually add that effect to this. So can you imagine if you want to add different effects, right? You want to have like when he goes up, there's one effect. When he lands, there's another effect, right? When he runs, when he dances, you want other effect, no problem. And who does it? The artist, right? So you don't have to go to the programmer and say, okay, when the animation is at this frame, play this particle effect. So normally in code, what do you have to do? You have to go, is the animation playing, find the full length of the animation, find the frame of the current animation, and then trigger, right? That's a whole bunch of code as well. So now, programmer, you don't even have to tell the programmer, right? Programmer just takes the file, plays, hey, there's an animation. Oh, cool, there's an effect. Super fast, super easy. So you can add these events to your animation, to your state machine. So if I wanted, I can add audio as well, right? So in the same script, I go play effect, play particle, play sound. So I can go, right? So I can even add sounds like that. When I hit jump, I go, and then boom. So now imagine, right, when you have some super cool fighting animation, right? You've got your character and he's going to do like, you know, some massive spell kind of thing. It's super easy, right, with Mechanim. And this works with 2D as well, right? With 2D characters, with 2D animation, all fully using Mechanim. Right? Super simple, super nice, super easy. It's really, really cool. That's why it's so exciting for me, the Mechanim animation system. Cool? All right. Any questions? Let me just see if there's any other examples I can show.
Can I ask a question?
Yeah, sure.
With the navigation maps before,
Yep.
can you make one of the more passable by plane
If you remove the collision.
with the collider?
Collider, yes. Yeah. Yeah. So as long as an object has a collider, then the navman will go around it. Yep.
So
Yes.
you just remove the collider.
Yep. And it will just work. And we just find, let's see. A little quick, just a simple test that I was working on. So all that is animated inside Unity with Mechanim, right? So has anyone ever played with 2D stuff? Right? Yeah. So this is really easy to do. You just load in the sprites, create animation. So you create all the animation inside Unity using the animation timeline. Take a quick look at it here. So as you see over here, you've got the animation here. So yeah, so as you can see, I click on each one. Right, each one has its own little animation. This guy, this whole guy has his animations here. Right. So you edit the animations actually in Unity itself. I'm just going to screw up this animation a bit. So let me just do something else to do it. And there's that. And so immediately like each way the same, right? So you can actually animate everything inside here. Use the state machine to set up the different animations, and then you're ready to go. So this was me actually because I wanted to test the UI, right? So I wanted to test the animation and for like a title screen UI, right? And so instead of making the art and then going to a programmer and saying, can you make the scene, can you make it move? It was like, I don't even need to talk to the programmer. I sit there, do everything, right? And then try it, and then I build to device, because that's the other thing I always do. I like to build to the device that we're working on. So then I can look at this animation on my device and go, okay, that looks nice, all right. And super fast, super easy. right? So you don't have to take the team's time to actually test things. Or you don't even have to, like, again, put something in and then, like, 1 week later, after they put it in, then they come and tell you, no, it doesn't work nicely, right? So this way artists can quickly go through and look at the problems, see the issues, while everything is being coded, and then go like, okay, I'm done, I want this effect, here you go, right? Because there are also times, right, and I'm sure some programmers will admit this, where the artist will come up and say, I want this thing to move here, and move there, and move around, and bounce, right? And the programmer's thinking, oh my God, it's going to take me 2 days of coding. What can I do? Right? So then, and it's true because it takes a lot of time, right? To sit there. So then what happens is, programmer will just put, nice one motion, and the animator will be like, no, I want it to curve like this. And the programmer's like, oh, curve. I got to think of the LUT formula. Oh, no, cannot. Right? So then, this one is like, go to the programmer, I want to make it curve. Programmer's like, go make it curve. Right? Do what you want. Then create the animation, create the keyframe, do what you want. Give me the file, I just play it. That's all they do. Right? Code just takes it, goes, play, okay, and you're done. So to me, it just builds, the production time is so much faster. Right? So cool. That's my presentation for today. Are there any questions? Yes.
Is there any difference for shaders and compute shaders?
There is. I don't know.
No.
But there is. But I really don't know. It's one of those. I play around with shaders, but I've never got into the heavy shader code. So.
Oh, the compute shader is for the heavy shader.
Yeah. Well, I don't know.
Oh, yeah, no problem.
So I'm saying I don't know because I never got into it, and so I've never actually looked at it. It might be something simple like, well, compute shaders are probably like either vertex shaders or pixel shaders. And, yeah, I just never looked that far. I played around with shaders, but I never looked that far because I'm, use a shader editor.
Oh.
Hey, woo! Exactly. Yes. So yeah, so I'm not sure.
Okay, thank you, Mr. Johannes, for this wonderful sharing. So we're still.
Really? I'm done?
Yes, you still want to continue.
I think if there's more questions.
Yeah, we still have time. So if there's any of you who still want to ask some questions. Anyone?
Yes.
What does Unity have that other game engines don't?
I just spent 2 hours about what another game engine doesn't have. Yeah, so it doesn't have it.
But Unreal Engine has some kind of similar.
It doesn't have root motion. It doesn't have, yeah. It has retargeting. It doesn't have root motion. It doesn't have state machine. The state machine like this. Yeah. Doesn't have.
Other things.
What's coming up in Unity 5? It doesn't have. So the light mapping system is enlightened. Okay. Currently, Unreal doesn't have it, but they're also trying to get it as well. It doesn't have the audio chips that we have. And I think the biggest one for me is that it doesn't have all the platforms we support. Right? They're still catching up as well. So, and so far they've only talked about iOS. They haven't been talking about Android. And they haven't been talking about OS X, right? Mac OS as well, right? Yeah. So we're way over that, right? There is a slight comparison in terms of usability, where Unreal has Blueprint, right, which has a visual coding system, but ours is all code. And it actually depends on how you work, because Blueprint can also get very messy as a visual coding thing. Where here, because it's small component based, you can actually make small scripts, right? So it's a balance. And I think for me, so I use both. And before I joined Unity, I was teaching in a university, and I taught both as well. And again, like I said, I still use both, right? But I love Unity for a few things. One is it's very easy to get into, very easy to do things like this, right? Unreal, yes, has some really awesome, 3D level tools and visual editor, but when it comes to 2D, I haven't had much fun with it. Unity works so much better. And the biggest one, I'll tell you right now, the difference between the two is that, and why I like Unity is because they pay me to be here. But think about this, right? Not they pay me, money to be here, but they pay for me to come here, right? They pay my flight, they pay my hotel, right? To actually come around and meet the community, right? Have you met? This is recorded, right? It's my job. Oh no. But well, I'll say it out, right? Even in my time when I was a developer, I've never met an epic evangelist. I've never met one, right? We've got 2 in this region, right? So after I'm gone, in the next couple of months, another guy will come around, right? And we want to do that. That's why I work for Unity, is because they support developers. They support the community, right? And to me, that's one of the most important things. Big difference.
One last question.
Yeah. There's 2. I'll take this guy first and then you. Yeah.
In shaders, I know there is fragment and vertex shaders. In Unity, is there split into 2 or only one? When creating new shaders, there is only one file.
There is one file. So it actually supports both.
Support both.
Yes. So Unity. So I may be wrong. Okay. But what Unity does is you can do things. You can actually use your HLSL code, right? Your typical shader programming. But it has an intermediate language as well called ShaderLab.
Oh, sure. Yes,
right. So ShaderLab is basically like a simplified version, yes. But you can actually just create normal
vertex and fragment shaders.
Yes, yep. You can, yes. So yeah, so have fun, knock yourself out. It's really cool. I've only written some very, very simple shaders. And I've only written it because I wanted some additional functionality. But again, I use ShaderLab, so it's like mostly like it's like a script kind of thing, right? Yeah. I can actually show you in a bit. You got a question?
I know that you is very useful for us developers, but for the pricing, I believe that most of us will agree that it is not very friendly for us startups and indie developers. Is there any programs that, any programs from Unity that can support us as the indie developers or students who wants to start making games with Unity for the pricing? I think it's not very friendly in terms of pricing.
Okay.
For the pro ones, is there any options?
I understand your question. So his question was, Unity's pricing is not very friendly for indie developers, students, right? So my answer typically is, free is not good enough for you. We give Unity free, right? So Unity free, right? You build on that, you publish your game on that, you make your money on that.
But with Unity logo in there.
Yeah, that's it. You make a game and you go make, like 10,000 US dollars. We don't even ask you for it, right? We only ask you, and this is the agreement, right? You use Unity free. If you make more than 100,000 US, right? Only then you need to buy Unity Pro. So no royalty, never, right? So imagine this, you go make your game with Unity free, publish it out, right? You make $500,000 US, you buy one license. That's all you do. 1,500 US, you buy one pro license. Although you made $500,000, right? So free is there. That's how much, that's where we are now, okay? And I understand your question. I think it's also people forget that free actually means you can publish. You can make money from it, right? Which tons of people are actually doing right now, right? It's just that you have a logo, that's it, right? The UT logo comes up in front. Small thing, right? And also, if you notice, every year, right, we tend to add certain things to free. So like for example, in Unity 3, right, the free version didn't have shadows, right? So you never had shadows in the free version. Unity 4 has shadows, right? We went pro feature, now free, right? So the next version, we're not sure, right? I can't say, but I'm sure there'll be things that'll be coming in that will be like, okay, you know what, this is going to be free. This is going to be free, right? So even like I was talking earlier about Unity Cloud Build. Cloud Build right now is pro, and even if you go on our website, it says we're working on it, it will be available for free as well. So we are truly trying to support as much as we can. The other part is, and I know it is a lot to go in terms of buying a pro license, right? But again, once you're starting to make $100,000 US a year, I'm sure it's, 1,500 is not too bad, right? And again, don't forget, they're paying for me to come here, right? Recording. I didn't say that. You're gonna cut. Okay. Any other? Yes.
When I have a character with a complex bone, and we want to make a life after we jump, we have a hair bone after jump, and the hair will go up.
Right.
Can we use the mechanism, because the mechanism always gets the bone?
Yep. A normal humanoid, right? Yes. So you can, but there are different methods. So his question was, here's a character, humanoid character which has hair that is also controlled with bone, and so it animates when you jump up, the hair goes up, and then when it comes down. So of course, the pure humanoid actually is just the character, right? The normal bone structure. You can add additional bones. Like I said, there's multiple ways to do it. Typically, one is to have the other piece as a separate mesh, right? That's one way. Another way is to actually use, for the hair, is to use morphing. So not bones. So the hair is controlled by morph targets, right? Which you then can, so then you can actually combine it together with your humanoid and use the mechanism. So you can attach anything. So the whole thing, the humanoid can be moving. This other piece can be a separate thing, but attached together and move at the same time. If you go to the asset store and you download the sample Unity Charm, you guys know Unity Charm? Yes. Yes. So have you tried Unity Charm? So Unity Charm actually has animated hair, right? Yeah. So it's a good example to use. Good? Unity Charm? Yeah.
Thank you. And now we're open for one last question before we end this. Anyone else? One more? No?
Before I end, I do want to say something.
Okay.
Okay. So before I end, I want to actually say, again, thank you for having me here. It's really an honor for me to come and meet you guys. One of the big things for me is that with Unity, and not just Unity, but game development. So how many of you here are students? How many here are students? Students. Right, a lot of students, awesome. That's really cool. All of you are game development students? All game development or related? You're not studying medicine or accounting? One hand. Medicine? No, accounting? No, okay. They're like, I'm an accountant, okay? I make money with games. No, but what I want to say is that for me, one of the exciting things about being a game developer is that it is such a new field, right, in the world. Anything else we do, like for example, engineering, accountancy, medicine, whatever, right? We're always catching up. We're always catching up with the West, right? Because they've had hundreds of years of advancement before us. Okay, so we're always playing catch up. For game development technology, it's a level playing field. So we're all equal. Every time new technology comes up, we're the same. We're all learning, right? So we are not playing catch up. We actually have an opportunity to be leaders. We actually have an opportunity to be ahead of everyone else. So like simple example, physically based shaders, what I'm showing you in Unity 5. That's coming out now, right? Artists all around the world, even experienced guys, right? It's something new. They don't know about it, right? So we're all the same. So in fact, right now, if you actually go Google physically based shaders, figure out what it is, how it works, then you will be actually on the same level, or you will actually be ahead of some of the artists in some of the big game companies. And that's how awesome game development is, right? You could actually be at a higher level. And I've experienced it throughout my career as well. Because game development is not about your position, your title, right? Number of years, right? It doesn't matter. It's what you can do. And game companies always look at that. It's about what you can do. So, any lecturers in here? Anyone lecturer here? Involved with school? No? Oh no. One. So it's also, but don't worry, I will come back to it. It's also not about your degree, right? It's not about that piece of paper. You go to school, you go learn, you learn the information, right? But you have to learn, you have to do. That piece of paper is not important. Your knowledge is important, right? That's the most important thing, right? I'm a developer for 20 years. I never went to university. I finished high school, right? I became a technical artist. I work with all kinds of people all around the world. I'm a Unity evangelist now, right? I came from a small kampung in Malaysia, right? And that's where game development takes me. That's where game development can take me. And it can take you as well. And the coolest part is this, for me, right? Game development as a profession is not locked to a country. It is global, right? You study law in Indonesia, you can't practice in Malaysia, right? You study law in Malaysia, you can't practice in Australia or Indonesia, you can't go anywhere, right? Except the country. You're a game developer, you're a programmer, you're an artist, you're a designer, they want you everywhere in the world, right? And I'm sure you out there, I've met today, like some of the guys who organized this event, some of the guys who are giving the talks, right? Your fellow Indonesians, yeah, they are also, they went abroad, they come back, right? They work in, big game companies, big animation studios. It's the opportunities available out there. Take the opportunity, right? Because I believe that coming here and meeting all you guys, you have so much talent, so much potential. Don't let it go. Now is the time, especially in game development. Things are changing. When change happens next year, there's all these new things, new technology, new devices, right? You can be leaders too. So don't let that opportunity go. All right? And then I get stuck like this. Thank you.
This is the end of the second session, and the next session will start promptly after a 30-minute coffee break. Now I invite you to enjoy the snacks and drinks prepared at the main lobby downstairs.
Wait, before you go, don't forget. Oh my God, you forgot, didn't you? Let me see. Oh, wait. Let me load up the. Yes. Oh wait, hang on. Where'd he go? Okay, here we go. All right, so take down that link. It'll take you to a little form, fill your name in, that kind of thing. And it'll be, so when you submit, it'll be sent. There will be a draw at the, it ends on December 31st. And beginning of January, there'll be a draw, and one of you who signs up, who's signing, will have a chance to win a Unity Pro license.
Participating, and we would like to inform you that there are various games on exhibit taking place at the main lobby as well. This exhibition consists of digital games from various international gaming partners. For anyone here who would like to order the country, activity